As promised, we'll start with a demonstration of how shockingly easy and how shockingly trivial it is to hack a mobile app. This demo has been put together by my colleague and friend, Neal Michie, product director of Verimatrix's award-winning code protection solutions. Based in Glasgow, Neal oversees Verimatrix's foundational security products that are relied upon by some of the world's leading corporations. Now, we're going to do this hack in real time, and you'll see how, in less than 10 minutes, your app secrets can be completely exposed to hackers with even modest capabilities. I mean, even I could do it. Now, due to legal restrictions, we can't just go and download someone's app from the App Store and go ahead and hack it and demonstrate it to everybody. It's not just embarrassing for a prospective customer, but it's actually illegal. So what we're going to do is we're going to use our own app, which is quite representative of the kinds of apps that many of you have out there. Also, to reduce the potential impact of Murphy's Law, I requested Neal to record a video of the hacking process, which we will now play. I will occasionally pause the video to explain critical elements in the video. And by the way, Neal's here backstage with us and will join us in the panel, so your questions can be directed to him at that point. What Neal's going to show in this video, which is about 10 minutes long, is how you can quickly open up an Android app and see the source code, how a hacker can look at the code to understand how the app works, and how he is able to make changes to the app to allow it to run in debug mode where he can then have full control over the app. We're going to start the video now. Please raise your volume so you can hear it clearly.
Hello and welcome. An image is worth 1,000 words, or so they say. So rather than discuss how vulnerable and how weak mobile applications are, I thought it was worth demonstrating how easy it is to open up an application that's installed onto a phone. I'm a product manager. I'm not a skilled hacker by any sense of the imagination. But that's really the point. You don't need any special tools to open up a mobile app. In fact, all the tools that I'll use in this demonstration are freely available and freely downloadable. While watching the demonstration, it's worth bearing in mind that criminal attackers are well-resourced and much more sophisticated than the sort of attacks we'll be showing today. Now, unfortunately, we can't use a real live application, and legal reasons prohibit us from doing that. So we'll be using a demonstration application. This is an app we use to promote our Protect My App service at trade shows, and has been set up to match as closely as possible apps that we see out in the wild. First thing we've got to do is pull the application from the phone. We do this using the standard debug tools that any Android developer will be familiar with. These tools use the same interface as the screen mirror I was using, which is why that's now disappeared. Once we've got the APK, which is the Android application package, off the phone, we can use an open source viewer to see inside the contents of the application. So very quickly we can see the application packages, and we can start to go into the source code of the application itself. We can see there's been some basic simple obfuscation applied to this application.
So what you've just seen is that Neal pulled the app from the phone to his computer and used an open source tool to look inside the APK. He is already able to see the source code of the app. That was, what, less than a minute. Let's continue.
The manifest file is a good place to start looking. This is where we can see how the application starts up and what's the first code to run. So in this case, the splash activity. An activity is Android speak for a screen. So this is the splash screen. On create is the starting of the screen. So as this is the first screen, the starting of the application. And we can see it kicks off a handler that runs 200 milliseconds after the app starts up. Not unsurprisingly, we can see that this does a wee bit of work and then finishes the activity, closes the screen. What's the work that it does? Well, this is this method B. It starts another activity, it starts another screen. which makes sense. We close the splash screen, we open the next one. And rather suspiciously, sitting here is an activity called rooted activity. So this is a screen which is doing something with root detection. And when we look closely, then we've got a toggle that switches between this rooted screen and the main screen. And this toggle is something to do with root detection. Known open source library.
So what just happened here at this point is Neal has figured out that some kind of open source root detection library is being used by the app. This most likely means that the app is checking whether the phone it is running on is rooted. Typically, this means the app owner does not want the app to run on a rooted device. For example, it could be a payments app, it could be a retail app, it could be a banking app. So we have already discovered that there is some root checking happening in this app.
The method being called was N here. And as you can see, it's a Boolean toggling between the two. So if we wanted to get this application running on a rooted phone, which is not meant to be, all we'd have to do is strip this back and make sure that it always opens the main screen and the root detection is bypassed.
And again, just to repeat what Neal just said, he's figured out how to bypass the root detection.
So what we've done so far is static analysis, reading the code. By reading the code, we can find interesting business logic, we can find security measures, precious IP, and basically everything about how this application is working. This allows us to build up a good understanding of how the application behaves and how it connects to back-end systems. But let's go further. Let's go and do some dynamic analysis. Let's see if we can watch this code run. To do that, we can use the standard Android development environment, Android Studio. And it allows us to open up the APK that we've been looking at for profiling, debugging, and analysis. So let's go and do that.
So our evil hacker, Neal, is now trying to run that app in debug mode. In case you're not very familiar with what this means, basically think of it this way. Running it in debug mode gives the hacker the ability to watch the app as it executes and learn about the app's functionality. It basically gives the hacker full control. So let's see how this continues.
As Android Studio opens up the APK, we can start to see inside it. We can see the classes, the manifest that we were looking at earlier. Here's the code that we had opened up before. But as I said, this is about dynamic analysis. So let's see if we can make it run. To do that, we hit the wee debug symbol. The application's installed onto the phone. It takes a second, but at the moment, it's not debuggable. By default, an Android application that you've installed from, say, Google Play is not debuggable.
So again, just to be very clear, we have learned that the app is not debuggable. So the default setting is that the app cannot be debugged. So like every good hacker, what's he going to do? He's going to try and modify the app. And he's going to make it so that it can be debugged.
So just putting it back on the phone and trying to debug it doesn't work out of the box. To make it debuggable, we have to go in and change the APK. We have to set it to be debug enabled. There's an open source tool called APK tool that we can use to open up the APK. You can see it opening up on the Finder window on the left. And there's our manifest file that we saw earlier. This time, we'll open the manifest into a text editor. And we will add the debuggable option to the manifest. Debuggable equals true. Save that. And then put our APK back together again.
So just as easy as that, he's changed the app to allow the app to run in debug mode. I mean, it's been really trivial so far. He opened it up, looked at the code, couldn't run it in debug mode, opened it up in a text editor, made the change, recompiled the app, and now the app can run in debug mode.
Before it will run on the phone, we have to sign it. I'll just use my own signing key for this. I don't need to have the developer's signing key. Any signing key will do. Right, let's go back to Android Studio and see if those changes have worked. Make sure we open the modified version. We'll keep it separate. And there's the app all opened up again. This time, if we look at the manifest, we can see, hopefully, that debuggable equals true. So let's see if that's all it takes to make this app debuggable. Starting the app, installing it onto the phone. It's installed. And bang. We now have a debugger attached to the application. So we can see the 15 or so different threads, processes that are running within this application. Now we're able to start digging in and seeing what it's doing as we interact with the application.
So I want to make sure that we're all very clear what we've seen so far. We've seen what could be a potential hacker take what could be your app, open it up, see the source code, easily read and understand the source code, make changes to the app, rebuild it, run it, and take control. That person is now able to watch that app run, watch the processes run, take control of processes, and see every part of how that app works, how it talks to your backend, how it interacts through the APIs, all of this. Now keep in mind that Neal has done this while pausing, explaining what he's doing. And all of this was about 8 minutes. If it was a real hacker, in under 5 minutes, the app would have been hacked. It's that trivial, under 5 minutes. So what can we do about it? Let's take a look.
As I mentioned, this is called dynamic analysis. And as you saw, it was very easy for us to tamper the application, to make it debuggable, sign it ourselves, and then put it back on a phone and observe what it's doing. From an attacker's point of view, this is very powerful, and from an app owner's point of view, it's very dangerous. It allows the attacker to observe in real time what the application is doing and how it's behaving. Basically, as an attacker, I have full control over the application. So moving on from the problem statement, how do we make life hard for attackers? How do we make these apps difficult to statically and dynamically analyze? This is where app shielding tools, such as Verimatrix APK Defender, comes in. These are tools that apply obfuscation, environmental checks, anti-tamper technology to applications, making them hard to reverse engineer, hard to modify, and hard to misuse. It doesn't take long to do, and in 5 minutes or so you can have an app protected. It's so important to be protecting your apps. The attacks we've shown today are just the start of a technical process that goes through to open up real business risks. These risks include lifting precious IP, attacking back-end servers, and finding vulnerabilities that can be exploited remotely and at scale within applications. This is why we recommend everyone developing mobile applications follows the OWASP Mobile Top 10 advice of hardening that code. Now we have the app protected. Let's open it up in the same open source viewer we used right at the start of this demonstration. Superficially, not much may have changed, though there is some simplification even at this high level. But more importantly, when we open up the code, we can see that before, when we had lots of clues to what the app was doing, things we could strip out to make it run easily, now it's just empty. There's nothing of interest there to an attacker. It's hidden, it's gone. And that's where protection comes in. It becomes very hard to reverse engineer an application, and it becomes almost impossible to change or manipulate the behavior. Thank you for listening, and I look forward to taking your questions during the panel session.
So, a quick summary of what you just saw. What Neal showed us is how to easily, trivially open up an app, look at the source code, and figure out what the app is doing. For example, we saw that the app tries to execute root detection. He made changes to the code, he recompiled it, and executed it with full control over the app. Neal also showed us how an app can be protected in under 5 minutes. Not hacked, but protected in under 5 minutes. In the interest of time, we've got a bunch of stuff to do today. What we did not show is other elements of our protection technology. For example, stuff that prevents the app from running in debug mode, that detects the presence of emulators and stops the app from running, that detects rooted devices or jailbroken devices and prevents the app from running on those. And also the anti-tampering technology that prevents hackers from making any change to your app or copying any part of your app. So that being said, Neal will be available for questions later.